All right. Hello, welcome. My apologies for the Zoom call not working this morning. I believe it was an issue with my computer, not necessarily Canvas. Either way, here are the notes. We're going to be doing most of 9.1 and most of 9.2 today. This is a chapter on transformations, so taking a shape and moving it or doing something to it to get a new shape. And so broadly, we're going to talk about transformations for a second, then we'll get into the specifics of 9.1. Okay, so a transformation is an operation that maps an original figure called the pre-image. Okay, so the original figure is called the pre-image and onto a new figure called the image. Pretty straightforward there, just some vocab for you. And you can think of the word maps as like transforms, or the way that I like to think about it is sends. So it kind of sends it off through whatever transformation we're going to be doing, and it appears at the target location. Okay, so a transformation is something that we can do to a shape. The original is called the pre-image. The result after doing that transformation is called the image. Now, a transformation can change the size of a figure. It can change the position of a figure. And it can change the orientation of a figure. One thing it will never change is the shape. It will still be the same shape. It will either be congruent and just rotated or translated, or it will be similar because it's been scaled up or scaled down. Okay, so that's kind of broadly some things about transformations in general. And so we're about to see our first one right now. So a reflection can be thought of as a flip over a line. Okay, and so over here on the left-hand side of the screen, you can see that this triangle ABC has been flipped over this vertical line to this other triangle with A with an apostrophe after it, B apostrophe, C apostrophe. The way that we say that in math is B prime. Okay, so anytime you see a apostrophe after a point, that would be B prime or A prime or C prime. So we flip A, B, C to A prime, B prime, C prime over a line that is called the line of reflection. Very creative name here. And I should probably spell the word reflection right. Reflection. There we go. Now each point and its image. Okay, so we can think of like the whole shape as being the pre-image and the whole shape as being the image, or we can think about each individual point as being an image or a pre-image. So this one would be the pre-image over here, and this would be the image after the mapping or after the transformation. So each point and its corresponding one on the image are the same distance from the line of reflection. Same distance. Okay, and that should make sense, right? If you're standing a foot away from the mirror, you appear to be 2 feet away in your reflection because there's 1 foot from you to the mirror, and then the mirror image has 1 foot from the mirror to you. Okay, so whatever this distance is from C over to the line, whatever that distance is there, it's mirrored on the other side to C prime. Okay. So some possible lines of reflection, the X and the Y axis, we are going to be doing a few examples of those. Okay, and there's some pretty neat little properties with that one. A little bit less often than the X or the Y axis, you can just do any old vertical or horizontal line. So remember, a vertical line has the form X equals a number, and a horizontal form has the a horizontal line has the form y equals a number. So this is vert and this is horizontal. Okay, and then the least common one that we're going to do, but perhaps the most interesting, is a diagonal line. And the two that we're going to see in this class are y equals x and y equals negative x. So if you've forgotten how to graph those, just think back to your slope-intercept form, and you should be good. Okay, so a reflection is a flip over a line. Each individual point on the pre-image is the same distance to the line of reflection as any point on the, or a corresponding point on the image. So they are equidistant from the line of reflection, and those are some lines that we're going to flip over. So here are a couple of examples. We're going to graph each of these and then flip it over the x-axis, and then we'll write down the new coordinates over here on the right. So point A is at -4, 2. Point B is at 4, 7. And C is at 5, 1. So there's A, B, and C. And if we connect those dots with even kind of straight lines here, it doesn't have to be perfect art, we are going to be flipping this over the x-axis. And so what I'm going to do here is I'm going to kind of highlight the x-axis here as our line of reflection. There it is, it's nice and blue. And so the way that we find where A prime is we say, hey, look, the distance from A to the line of reflection is 2 units. And so the distance from A prime to the line of reflection should also be 2 units. So there's A prime. C is 1 unit away, and so C prime just needs to be 1 unit away. And then B up here, you can kind of draw a nice vertical line there. That's 1, 2, 3, 4, 5, 6, 7 units up. So our B prime will be 1, 2, 3, 4, 5, 6, 7 units down. There's B prime. And then if you connect the dots here, you've got a triangle that has been flipped over the x-axis. You can think of this like highlighted blue line in the middle as being like a mirror. Okay, and then just reading the coordinates of each of those new points off of the graph. A prime is at -4, -2. B prime is at 4, -7. And C prime is at 5, -1. Like that. Okay. And if you notice, the points A and A prime here, they only differ by a sign on this y coordinate, right? Think about flipping something from the positive side of the x-axis to its exact position, but on the negative side, all of those y values are going to be exactly the same, but they're going to be negative. And the x values aren't changing because we're not shifting it left or right. We're not reflecting it over the y-axis. The only thing that a flip over the x-axis does is it changes the positives to negatives in the y spot. Okay, so just a neat little shortcut there, if you will. Next up, on number 2, we've got a rectangle PQRS with vertices P at 1, 2, Q at 2, 5, R at 8, 3, and S at 7, 0. So here's P, Q, R, and S. And we can connect those dots there. Oh, I put S incorrectly on the graph. S should be at 7, 0, not 6, 0. And connecting our dots, we've got a beautiful little rectangle there. We are going to flip this over the y-axis. So I will highlight the y-axis again. Well, I guess I did the x-axis last time. Okay, and we're just going to do the same idea here. We're going to take the distance from P to the line and then mirror that onto the other side for P prime. So the distance here is just 1. So the distance here should just be 1. That means that this right here is P prime. Q is 2 units away, so Q prime will also be 2 units away. R is 8 units away. That's how wide this graph is. So it's going to be 8 units away on the left side for R prime. And then finally, S is 7 units away and sitting on the x-axis. So S prime will also be that distance, just in the opposite direction. And there is our mirrored or reflected rectangle. And so to fill in the points, we can just read them right off the graph. P is at the point -1, 2. Q prime is going to be at the point -2, 5. R prime is at -8, 3. And S prime is at -7, 0. And if you take a look at these points and their originals, this time, since we reflected over the y-axis, the x values went from positive to negative and the y value stayed the same. Okay? So when you're reflecting over the x or the y-axis, you can just change the sign of one column, depending on which one you're doing. Okay. So number 3, we've got a trapezoid flipping over the y-axis. So F is at the point -5, -2. G is at the point -2, -2. H is at the point 0, -6. And I is at 8, -6. So this is F, G, H, I. And just connecting those dots there, we've got a lovely isosceles, nope, not isosceles, close to isosceles trapezoid. And we're going to flip it over the y-axis. That's what the problem says to do. The y-axis there. So I will highlight the y-axis. There we go. Kind of messy, but that's okay. And notice all we have to do to flip this guy over is G is 2 units away. So G prime will be 2 units away. F is 5 units away. F prime will be 5 units away. I is way over here on the edge. So I prime will be way over on the edge. And H is actually already at its reflected spot. It's on the line of reflection, so it doesn't need to move, right? If you touch a mirror, the appearance of your finger appears to be 0, right? Excuse me, sinuses have been acting up. Okay, so I'm going to connect the dots there and we'll have a nice pretty picture. But H and H prime here are exactly the same, but reading off, F prime is going to be at 5, -2. G prime is going to be at 2, -2. I is at 8, -6. I need to put that in the right spot. 8, -6. And H is still at 0. Sorry, H prime is still at 0, -6. All right. Moving right along, we'll do one more across the axes, then we'll do some arbitrary lines. So for number 4, rhombus WXYZ with vertices W, -2, -4. That's right there. X is 1, -2. Y is 4, -4. And Z is 1, -6. There we go. So that's W, X, Y, Z. Here's our pretty shape. Okay, lines don't connect all the way, but it doesn't really matter that much. And we're going to be reflecting this over the x-axis. So highlighting that. There we go. So W to W prime. So W is 4 units away right here. That means W prime will be 4 units away. Oh, I don't need to write 4. I need to write W prime. X is 2 units away. So X prime will be 2 units away. Y is 4 units away. So Y prime will be, and Z prime will be 6 units away because Z is 6 units away from the x-axis. And so here is our new reflected rhombus. And notice that the reflection changes the orientation and the position. Okay? Reflection changes the orientation and the position. Doesn't change the size though. I don't even know if we're going to get to the one that changes the size. We'll see. So W prime -2, +4, X prime 1, 2, Y prime 4, 4, and Z prime 1, 6. Those are the coordinates. Now, in class, we didn't do all of these examples. I think I did 5 and 7. No, I did 5, 6, and 7. I don't think I did 8, and then we'll do 9 and 11. So triangle JKL here, go back to red, has J at 1, -1, K at 2, 3, and L at 3, -2. So this is JKL. Excuse me for 1 second. Sorry, folks, had to sneeze. Connect our dots here. There's JKL, and we're going to be reflecting over the line x equals 4. Now remember, x equals is a vertical line. X equals 4 is our line of reflection here. It's not the axis, but it is a vertical line. So K prime will be 2 units to the right because K is 2 units to the left. L prime will be 1 unit to the right because L is 1 unit to the left, and J will be 3, so J prime is 3. And there is our shape there. J prime appears to be at the point 7, -1. K prime appears to be at the point 6, 3, and L is at 5, -2. Okay, there are fewer there are fewer fancy patterns and stuff with reflections over arbitrary lines, but you can find them if you look hard enough. Number 6, we've got a square RSTU. So R is at 0, 3. S is at 5, 4. T is at 6, -1, and U is at 1, -2. So that's R, S, T, and U. I'm going to move that over just a hair because I'm going to need that space. All right, poorly drawn square, but I'm not an artist, I'm a math teacher. The line we're going to be reflecting across is x equals -1. That is this vertical line that I'm highlighting right there. And so r prime will be 1 unit to the left of it because r was 1 unit to the right. S is 6 units to the right, so S prime will be 6 units to the left. T is 2 units to the right, so, well, I guess I mixed up the order here, so, but as it's labeled, you know, actually, I'm just going to fix it. Sorry about that. That should be T, this should be U. So U prime, so U is 2 units to the right, U prime will be 2 units to the right. And T is at X coordinate 6 plus the 1 here to get to -1. So that's 7 units to the left. It looks like T prime will be right there. And there is our transformed square. R prime has the coordinates -2, 3. S prime has the coordinates -7, 4. T prime has the coordinates -8, -1. And U prime has the coordinate -3, -2. Okay. So I'll do number 7. I'll skip number 8 because I'm just trying to get through this really quickly. So number 7, we're going to be flipping over a horizontal line, the line y equals 2. So let's plot the points. -4, -4 is right here. That's C. D is at -2, 0. So C, D. E is at 6, 1. 6, 1. And F is at 4, -3. So 4, -3. So C, D, E, F. And so here is our parallelogram. Not the best art in the world, but you get what you get. Now, the line y equals 2 is this horizontal line that I'm highlighting that goes right through my letter E. So C prime, since C is 1, 2, 3, 4, 5, 6 units down, C prime will be 6 units up. D prime will be 2 units up because that is D is 2 units down. E is just 1 unit up, so E prime is right there, and F prime is 1, 2, 3, 4, 5 units up, so 1, 2, 3, 4, 5 right there. So C, D, E, F. Oh man, my art is not good today, but the content is still fine. So C is at the point -4, 8. D prime is at the point -2, 4. E prime is at the point 6, 3, and F prime is at the point 4, 7. All right. So we're going to skip that one. You can do it if you'd like on your own time. I want to do 9 and 10 because they are talking about the diagonals. Actually, 9 and 11. They're talking about the diagonal lines. And I'm actually going to go ahead and draw in the line y equals x. It's this diagonal line that joins the lower left corner to the upper right corner. That's y equals x. So in red, I will go ahead and plot these points. X is at -5, -2. Y is at -3, +4. And Z is at -1, 1. So there's that. That's X, that's Y, that's Z. And I'm going to connect my dots here so I have a pretty triangle. And so it's maybe a little bit difficult conceptually at the beginning to think about how we might reflect this over a diagonal line, but we're going to use the same technique. We're going to find the distance from Z to this line, except for we're going to like flip halfway through. So what's going to happen is either go horizontally or vertically first. Okay, and then go until you hit the line of reflection, then go the opposite way. So then go vert or horizontal the same number of units, okay? The same amount. Okay, so that may not be great English, but you'll see it in just a second. For this problem, I'll start with X. Okay, I'm going to go horizontally first because why not? And if I go horizontally, I go 3 units to get to the line. Now that I've hit the line, I'm going to go that same distance vertically. Okay, and where you end up, this point right here, that's X prime. Okay, for Y, I've got to go over 1, 2, 3, 4, 5, 6 units. So I need to go 1, 2, 3, 4, 5, 6 units there. That is going to be Y prime. I don't need that little dot there. And Z, if I go over, is 2 units. So I need to go down 2, and that's going to be Z prime right there. And there you have it. I have the triangle XYZ reflected across a diagonal line, X prime, Y prime, Z prime. I'm going to skip number 10 because it's the same. I want to show you the example on number 11 because we're just going to flip over the other diagonal line that we can draw on the coordinate plane here. But the idea for flipping across a diagonal is you either go horizontal or vertical first, and then when you hit the line, you go the opposite direction. So if I was going horizontal, then I go vertical. If I was going vertical, then I go horizontal. Okay. So take a look at number 11. We've got the line y equals negative x. I will draw that in right now. Y equals negative x connects the top right to the, or top left to the bottom right. So we'll go ahead and put the original on here in red because that's my MO. -1, 3 is our first point. 0, 6 is our second point. So there's A, B. And then C is at 3, 5. And then D should be right down here at 2, 2 for a nice small square right here. Okay, so again, we're gonna do that. You know, maybe what I'll do is I'll do the lines in green. For A, if I go horizontally, dang, I want to do green. Okay, there we go. For A, if we go horizontally, we go 2 units. And so we're going to go down by 2 units vertically to get to A prime. I'm actually just going to I'll put the shape in blue, but the lines in green. B, I need to go 1, 2, 3, 4, 5, 6 units there. So I need to go 6 units down. There's 4, 5, 6. That's where B will end up. C, so now I can start going vertically. It doesn't matter which one you do, as long as you are consistently flipping it when you get to the line. 1, 2, 3, 4, 5, 6, 7, 8 units. So C needs to go over by 8 units. 1, 2, 3, 4. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. That's where C is going to be. And then D, I'm going to go down by 1, 2, 3, 4, and over by 1, 2, 3, 4. That's 4, 4, 8. Got everything labeled there. And the endpoints of all of these green lines is where our points, that's A prime. This right here is B prime. This one right here is C prime, and this one right here is D prime. And then if I connect my dots as well as I can, that right there, if you look, I guess if you tilt your head a little bit to the left, you can kind of tell that that is the square that has been reflected exactly over that line. Okay. And coordinates, A prime is at -3, 1, B prime is at -6, 0, C prime is at -5, -3, and D prime is at -2, -2. Alrighty. How about that? So that's all of our notes on reflections. And here we took a break for lunch. So if you would like to pause the video and take a break, you may do so. Then we started on the 9.2 notes, which is translations. And this one is pretty straightforward. This one is not super complex here. So let me pull out the red pen, take a sip of water, blow my nose, and we'll get started. Okay, here we go. So a translation is a different kind of transformation, and it's literally just vertically or horizontally sliding, also known sometimes as shifting. Okay, a slide or a shift. And if you actually had like a physical trapezoid in this case, and you just grabbed it and slid it across the paper to the right and down, that's a translation. Now, mathematically, we want to be precise about these things. We want to have very well-defined notation, all that stuff. The symbolic form that we use is that any point x, y will get slid to or shifted to or translated to. A lot of the times this arrow also means mapped to, and you heard that word in the previous notes, x plus h for the x coordinate and y plus k for the y coordinate. Okay, and what this means is that the x coordinate is going to be added onto by some certain value h. So h represents what is known as the horizontal shift, and k is represented or represents the vertical shift. Okay, and when you think about it a little bit, if you have I'll do it right here. You have x plus h. That means your x value is getting bigger, which means you are shifting to the right. But if you have x minus h, that means your x value is getting smaller, which means you are shifting to the left. And then if you have a y plus k, that means your y value is getting bigger. That means you're going up, farther away from the x-axis. And a y minus k means you're moving down. Okay, so x plus h to the right, x minus h to the left, y plus k up, y minus k down. And actually, fun fact, when you get to Algebra 2 next year, or soon, I guess, the x's actually swap. So minus would be right and plus would be left, but don't worry about that just yet. Worry about that next year. Okay. So for number 1 here, we're going to go ahead and plot these points, -6, comma, -1. That's right there. That's Q. -3, comma, +1. That's going to be R. S is 1, comma, -5. 4, 5. There's S. And T is at -2, -7. There's T. And I'll connect those dots so that we have a nice, pretty rectangle. And so there's a couple of different ways that you can translate these things. If you want to do it geometrically, then what you should do is you should look at this transformation and say, that x plus 5 means I'm going to the right by 5, and the y plus 7 means I'm going up by 7. And then what you would do is you would take each of these points and move them right by 5. So 1, 2, 3, 4, 5, and then up by 7. 1, 2, 3, 4, 5, 6, 7. And that would be Q prime. You don't have to draw these little like horizontal and vertical bars every time. I'm just doing this for the first example as an illustration thing. So R would have to also move 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5, 6, 7 up. There's R prime. S prime, you could do the same way. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. There's S prime. S prime. And then T is 1, 2, 3, 4, 5 as well. 1, 2, 3, 4, 5, 6, 7. There's T prime. And as you can see, when I connect all of these, I do get a rectangle Q prime, R prime, S prime, T prime that has been moved up by 5, or sorry, up by 7 and right by 5. It does not matter if you go up first, then right, or right first, then up. The order in which those happen does not matter. Okay, so reading off of the graph, Q prime has coordinates -1, 6. R prime is at 2, 8. S prime is at 6, 2, and T prime is at 3, 0. Okay, so that's kind of the graphical way to do it. And for number 2, I want to do it in maybe a little bit more of an algebraic method. So I will go ahead and graph the first one. So CDE, C is at 2, -1. D is at 7, -4. And E is at 4, -6. So 4, 1, 2, 3, 4, 5, 6. So there's C, D, E. And so instead of drawing all over the graph and having a bunch of like lines connecting C to C prime or D to D prime or whatever, we can take the coordinate C, which is 2, -1, and we can put it at C prime just by doing 2 and then -3. And then Y, which is -1, sorry, plus 8. So with the blue, what I could do is I could say 2 -3 from that part, and -1 plus 8 from that part. And that right there will just tell you what the coordinates of C prime are. C prime is at 2 -3 equals -1, -1 plus 8 equals 7. And I can just go ahead and plot that point. -1, 7 is up there. There's C prime. I could do the same thing with D. So D was at the coordinates 7, -4. And so D prime will start at 7 and -4, but algebraically what we're doing is we're subtracting 3 from the x and adding 8 to the y. So 7 minus 3 is 4, and negative 4 plus 8 is 4. So D prime will end up at the point 4, comma 4. There's D prime. And once more unto the breech, E is at the point 4, comma negative 6. So when we move that to E prime, we start at 4 and negative 6 for the X and the Y, but we apply the transformation by subtracting 3 from the X and adding 8 to the Y. That will give us coordinates 4 minus 3 equals 1, and negative 6 plus 8 equals 2. So 1, comma 2 would be E prime, and there it is. There's my C prime, D prime, E prime moved triangle. And notice it got moved to the left by 3. So let me get a dotted line there, left by 3 and up by 8. So algebraically and geometrically, let me just redo, erase, rewrite. There's the 8, and there's the 3. Okay, each of those points got moved 3 left and 8 up. And whether we did it geometrically or algebraically, we had the same thing. Okay, so you can kind of pick and choose which method you like better. I like just going geometrically because it ends up being less writing, as long as you don't have the little vertical and horizontal connecting lines each time, like from C to C prime, D to D prime, E to E prime. As long as you don't have, like, as long as you can just count with your pencil and you don't have to draw those lines out every time, then I think the geometric way is a little bit easier. So let's go ahead and plot the vertices of this rhombus for number 3, negative 4, comma 7. That's J. K is at 0, comma 8. L is at negative 1, comma 4. And M is at negative 5, comma 3. So here's my original. And we are going to be shifting it to the right by 2 and down by 2. Okay, so I'll just do this point by point on the graph. K looks to be the easiest. Right 2, down 2 goes right there. There's K prime. L, right 2, down 2, there is L prime right there. J to J prime, if you go right 2, then down 2, you end up still inside of the original, but that's okay. There's no rule saying that when you translate it, you have to be outside of the original. So J to J prime is fine. And M to M prime, 2 right, 2 down. There's M prime. And so our new transformed figure looks like that. And so we can fill in these coordinates just by looking at the graph or by adding and subtracting to the listed coordinates above. I'm going to look off the graph. I've got negative 2, comma 5 for J prime, 2, comma 6 for K prime, 1, comma 2 for L prime, and negative 3, comma 1 for M prime. Okay, I'll do one more example, and then we're going to flip to the back of this to do a new kind of problem, 2 new kinds of problems. Just one more example here. Number 4, square WXYZ. So let's get those vertices down, get that pretty picture out. 1, comma 7 is W. X is 6, comma 5. Y is 4, comma 0. And Z is negative 1, comma 2. Okay, so this transformation right here, or translation, I should say, is to the left by 7, because we're subtracting 7 from the X, and down by 6, because we're subtracting 6 from the Y. So just kind of counting it out here, left by 7 puts me, and down by 6 puts me right there. So I think that's W prime. Left by 1, 2, 3, 4, 5, 6, 7. Down by 1, 2, 3, 4, 5, 6. Yeah. Then Z prime is probably the next easiest one. Left by 7 puts us on the very edge. Down by 6 puts us at Y is -4 there. There's Z prime. X prime, if you go left by 7, you're here. And if you go down by 6, you are here. That should be X prime. And then Y prime, left by 7, down by 6, should be right there. Okay. Translations, as long as you can think about it geometrically, are fairly easy. Translations are just picking it up and moving it and finding the new coordinates. So W prime is at -6, 1. I'll get out of here. X prime is at -1, -1. Y prime, I forgot to write it there, is at -3, -6. And Z prime is at -8, -4. Okay. So I'm going to go ahead and skip 5 and 6. Number 7 and 8, they actually gave us the two drawings and are asking us to find the rule. So the rule is always going to start with X, Y getting mapped to X plus something, Y plus something. So you can always start this problem out with just go ahead and writing in a template here. And all you need to do is connect D to D prime using vertical and horizontal lines here. And count from D up to this corner. So that's 1, 2, 3, 4. So we're adding 4 to the Y's, right? And from that corner over to D prime is 1, 2, 3, 4, 5, 6, 7. We're adding 7 to the X's. So the X's are getting bigger by 7, and the Y's are getting bigger by 4, and that is the rule. Now, it's a good idea to check this one more time, just like from E to E prime. And indeed, we did get 4 and 7 again. Okay, just make sure that you check it so you don't accidentally count wrong and get the wrong answer. Okay, so we spent the last couple of problems doing rule to diagram, and now we can go diagram to rule. No problem. And for number 8, we'll do the same thing here. I'll just go ahead and start by putting X, Y gets translated to X plus something, Y plus something. And M looks to go up by 2 and left by 4 to get to M prime. So up by 2 would be a plus 2 on the Y's, and left by 4 is actually a -4 on the X's. So be careful there that you don't put the X's with the Y's or the Y's with the X's like I almost did. And also be sure that if you are moving left or down, you write a minus. Right or up, you get a plus. Okay. Now I'm going to do, let's do 3 of these just because why not? Let's do 9, 10, and 12. They are going to give us 2 transformations. And in class, I couldn't, well, initially I couldn't decide whether or not we were going to do one and then the other, or if it was just doing 2 separate problems on the same graph. I believe that they are asking us to do one, then the other. So what I'm going to do is I'm going to do the original in red, the first one in blue, and the second translation in green. Okay. So let's go ahead and get the initial triangle on here. We've got X at -3, 7. Y at -2, 1. There's Y. And then Z, we're going to go -5, 2. There's Z. So my triangle X, Y, Z looks something like that. All right, and the first translation we need to do is to reflect over the x-axis. So I'm going to highlight the x-axis. And we're going to reflect it over. So y is 1 unit up, so y is going to map to 1 unit down. Z is 2 units up, so it's going to reflect down to 2 units down. And x is 7 units up, so it's going to reflect to 7 units down. And I just want to make a brief note here. There are 2 notations you can use, and I'll tell you why I choose the one that I'm going to choose. The first is to go from x to x prime to x double prime. The second is to go from x to some other notation like x star to x prime. And this is the one I'm going to use, the second one, because first of all, the answer is asking for x prime. And so if I have x prime on the graph, it's confusing as to whether or not the final answer is prime or double prime. And second of all, x star here is actually a pretty standard notation in mathematics for some kind of intermediary value. Okay, it's somewhere in the middle of our calculation. It's not our final one, but it's not the beginning one. It's just something in the middle. So x star denotes something in the middle. That means that this point that I reflected here is going to be called y star. This one down here is going to be x star, and this one is going to be z star. And so that's the notation that I'm going to use for the first transformation. And then what we're going to do is we're going to apply this translation of right by 9 and up by 2. Okay, we're going to apply this transformation of right 9 up 2, and so x is going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9 up 2. So that's a 9 and a 2, and x star will finally land at x prime, our final resting place here. Same thing for y. Y is going to go right by 9 and up by 2, and that's going to be y prime. So y to y star to y prime. And then z is going to go right by 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up by 2, right there on the x-axis, z prime. So this is a little bit of mixed practice here. We're going to be doing two transformations to the same shape. And you can read these off of the graph here. X prime is at 6, -5. Y prime is at 7, 1, and Z prime is at 4, 0. Okay, so we plotted the original. We did the first transformation, which was a reflection, and then we did a translation after that. So we went from x to x star to x prime. All right. Numbers 10 and 12, and we're done. I'll talk about the homework. Parallelogram QRST with vertices 2, -1, that's Q, 7, 1 for R, S is 6, -2, and T is 1, -4. So that's Q, R, S, T. And then again in blue, we will apply the first transformation, which is to reflect on the line y equals x. So I'm going to go ahead and draw that line in. Y equals x. And we'll just do that same technique we had earlier where we go up by 3 and then over by 3, and that will be Q star, because we're not at our final spot yet, R will go up by 1, 2, 3, 4, 5, 6. So it'll go over by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. There's R star. S looks like it has to go up by 1, 2, 3, 4, 5, 6, 7, 8. So S is going to go 8 over 1, 2, 3, 4, 5, 6, 7, 8. There's S star. And T looks like it has to go up by 1, 2, 3, 4, 5 to get to the line. So now we're going to go 1, 2, 3, 4, 5 in the other direction of the line. There's T star. So connecting those lines, I have reflected over the line y equals x. And if you kind of, oh, what did I do wrong here? Nope, that's right. I'm good. I turned my head the wrong way and it looked kind of funny. If you turn your head to the right 45 degrees, those two parallelograms should look like mirror images of each other. Confusing myself. Okay, then the translation in green is to the left by 3 and down by 7. So I'll take T first because it's kind of like the lowest one. T to the left by 3 and down by 7. 1, 2, 3, 4, 5, 6, 7. Goes right there. That's T prime. Pardon me while I sneeze real quick. Ugh, I hate springtime allergies. S star will go 1, 2, 3 to the left and 1, 2, 3, 4, 5, 6, 7 down. There's S prime finally. R will go 3 to the left, 7 down. 1, 2, 3, 4, 5, 6, 7. There's R prime's final resting place. And Q prime, 3 to the left. 1, 2, 3, 4, 5, 6, 7 down. There's Q prime right there. We can connect these dots like so. And then finally, we can read the coordinates off of the graph. So Q prime's at -4 on the X, -5 on the Y. R prime is -2, 0. S prime is -5, -1, and T prime is -7, -6. Okay, last one, and then I'll talk about the homework. Triangle, GHI. This one has the translation first, then the reflection. And the order in which you do these things does affect the result, okay? So this would not be the same as if we had done the reflection first, then the translation. So let's get the original up, excuse me, in red. G is at -1, 6. H is at -1, 3. And I is at -6, 6. There's G, H, I. Okay. And the first thing we're going to do is we're going to translate it. So this translation is right by 7 because the X is getting larger by 7, and down by 5 because the Y is getting smaller by 5. So if I go to the right by 7, G will end up over this way and then down by 5. So it goes 1, 2, 3, 4, 5. That's G star. H star is just 3 units down from G star because H is just 3 units down from G. But you can also do the 7 right, 5 down thing. And then I is 5 units to the left of G. So I star will be 5 units to the left of G star. Remember, whenever you do transformations, you don't actually change the shape. And translations here and reflections do preserve the distances from one to the other. So we're not changing the size. Okay. So it's G star, H star, I star. Oh, there you go. And then the next thing we need to do, and the final thing we need to do, is flip over the line y equals -3. So y equals -3 is this horizontal line right here. Okay, so we need to flip it over this line. H star is 1 unit away, so H prime will be 1 unit away. G star is 1, 2, 3 units away, so G prime will be 3 units away, or sorry, 4 units away. And then I star is 4 units away, and so I star, or I prime, will be 4 units away. And here is our final triangle in green. Okay, reading off the coordinates, we've got G prime is at +6, -7. H prime is at +6, -4. And I prime will be at +1, -7. Okay. So that's all the problems that we did in class, maybe even one extra, I don't remember exactly. But since we covered 2 sections, I assigned 2 homework worksheets. Let me pull those up for you. The 9-1 homework and the 9-2 homework. So the 9-1 homework just goes over reflections, okay? But it's only 6 problems. And the 9-2 homework just goes over translations and has a couple of those mixed practice ones at the end. And it's only 10 questions. But since I only want to give you 1 homework assignment per day, I've asked you to only do the odd problems. Okay, so for the 9-1 and 9-2 homework, you're only going to be completing the odd problems. I've got both of those in the same assignment. It's called the 9-1 and 9-2 homework assignment. And you download both worksheets and only do the odd problems, okay? And then you'll upload that as a single upload. You'll get full credit for it if you do it, if you try it. Even if you mess up a time or 2, all I want you to do is try and get used to these ideas of transforming, because the precision comes with practice. Okay, so that will be due officially on Tuesday. Even though we've got FSA, I'll probably be a little flexible about these deadlines. So thank you for being patient with the Zoom earlier. And if you're going to watch this over the weekend and do the homework like a good student, I thank you as well. All right, have a good weekend. I will see you next week for FSA testing.